There are places in the universe where light bends. That's expected, where gravity curves the path of photons and stretches galaxies into arcs. That's beautiful. And then, there are places where something else happens, where light doesn't bend. It disappears. It began, as many things do now, with data, not a telescope in the classic sense, but a nested series of deep-field radio arrays. Satellites orbiting the outer limits of Earth's magnetosphere, collecting time-lapse data from a distant, ancient region of the sky. The system stitched together countless long-exposure observations to map gravitational lensing effects around a cataloged black hole near the galactic rim. Nothing unusual, until an intern ran a redundancy check. It wasn't what she found that mattered. It was what she didn't. Frame 1439 in a sequence of 2,600 missing. Not corrupted, not blacked out, gone. And yet, the sequence timing remained uninterrupted. There was no stutter in the timestamps. The system didn't log an error, as if the array had captured something, processed it, then replaced it with silence. At first, they blamed compression artifacts, a faulty metadata flag. But when the raw photon count was examined, they found something worse. The photons themselves had no path history, no entry vector, no impact record, like they had appeared without ever traveling. The silence in the data wasn't just absence. It was a hole in time. They went back through the telemetry logs. Around frame 1439, the sensor temperature dropped by 0.2 degrees Celsius. Unusual, but within tolerances. The software flagged no memory spikes. But one engineer noticed something off in the instrument's internal clock logs. A stretch of 7 seconds had been overwritten. Again, not deleted, rewritten. The log entries bore the same format, the same precision timestamps. But the waveform data attached to them didn't match the recording parameters of the equipment. It was like the telescope had continued functioning, but the version of the telescope doing the recording wasn't quite the same one anymore. The team rechecked the black hole's known coordinates, its mass estimate, its accretion disk projections, all held, but then they compared archival data from another deep array, a European observatory running a parallel lensing map years prior. That black hole showed a different pattern. The same mass, the same bend, but a different alignment, only by a fraction. A deviation so small it would normally be chalked up to error margin. But not now. Now it looked like the black hole had changed the angle from which it had been seen. Not moved. Reseen, the lead astronomer, proposed a radical question. What if this black hole doesn't just curve space? What if it curves context? What if the moment you observe it, you're not just seeing gravity at work, you're seeing a version of reality shaped by its proximity? And worse, what if every attempt to re-observe that moment, every reprocessed frame, every timestamp audit, every photon simulation, only takes you further from the truth, like trying to rewind a dream you never had? In physics, lensing is straightforward. Mass warps space. Space bends light. But this anomaly didn't warp light. It dropped it. Frame 1439 had photons that existed without lineage. And if photons have no past, then what observed them cannot exist in causal space. To the astrophysics team, the implications felt theoretical, distant, academic. But to the intern who found it, the moment felt wrong in a more primal way. She said, "I stared into that missing frame too long. I felt like it was staring back." The anomaly spread. Over the following months, other observatories reported brief drops in telemetry around the same region. Not loss, perfect data that recorded nothing. Sometimes for milliseconds, sometimes entire frames. The phenomenon was soon dubbed causal deletion. Not absorption, not noise, but the erasure of causality itself. A moment rewritten so cleanly that even the systems recording it believed it had always been so. One physicist proposed a horrifying possibility. What if black holes are not the end of matter? What if they are the event horizon of knowability? Not where light fails to escape, but where the story of light can be unwritten. And if that's true, then there may be places in the universe where reality itself is optional, where the past can be edited by proximity to gravitational intent. And if a black hole can erase its own visibility, then it can erase the memory of being observed. That's when the audit logs vanished. Not all of them, just the backup for frame 1439. Gone from local servers, gone from cold storage, gone from the redundant analog tape they weren't even supposed to still use. 3 copies, 3 methods, 3 disappearances. One technician found a CRC checksum file still intact, meaning the backup had existed, but the system registered it as never restored and never deleted, like it had never been created in the first place. That's when the team stopped trying to retrieve the frame. Not because they gave up, but because some of them feared what might happen if they succeeded. Not everything that erases itself is broken. Some things erase themselves because they were meant to. The brain is not a camera. It doesn't record. It rewrites. It edits. It overwrites details, substitutes rhythm for fact, and calls that process memory. But what happens when the thing we're remembering rewrites us back? It started small. A senior astrophysicist, Dr. Rohn, was assigned to reconstruct the lensing data from the original frame 1439 incident. His task wasn't recovery, but replication. Feed the original variables into new simulation engines. See what kind of models could explain causal deletion. At first, it felt routine, until he noticed the handwriting in his own notebook, one he kept meticulously since graduate school. He found a page filled with equations, not unfamiliar, but slightly off. Logic loops he wouldn't use, curvature assumptions he wouldn't make. The ink was his, the pen pressure matched, but the math didn't feel like his thinking. He dismissed it as an old trial run, something copied from an early draft. But as the days passed, the equation came up again, in simulation results, this time from code he hadn't modified. The model that used those equations fit the anomaly better than any other. A perfect explanation. From a formula he had no memory of creating. His discomfort deepened. The software logs began behaving strangely. Not corrupting, not crashing, but looping. Terminal commands repeated themselves days later. Identical keystrokes, same session time, same task. But he hadn't run them twice. Once, a simulation log displayed the same result 3 times across 3 different timestamps. But only one of them appeared in the server history. It wasn't duplication. It was recursion. The system wasn't replaying data. It was remembering too much. He brought it up to the other researchers, quietly, off record. But they'd noticed things too. One had found a time-lapse animation in their shared drive that no one remembered rendering. Another had received an automated backup alert, one the system hadn't sent in 5 years. The telescope's own thermal diagnostics began reporting values from old test patterns, patterns only used during the original 1439 investigation. Not archived files, live telemetry. The hardware was functioning. The sensors were clean, but the numbers were from another time, and they kept coming back, as if the telescope wasn't looking into the black hole anymore. The black hole was looking back through the telescope. Dr. Rohn began journaling, manually on paper. Each day, a new entry, signed and dated. He hoped it would stabilize him. It didn't. After 6 weeks, he found entries dated in the future. Thoughts he hadn't written yet. Emotions he hadn't yet experienced. He recognized his handwriting, his phrasing, even the little arrow he drew when connecting ideas. But the entries described events that hadn't happened yet. Until they did, the entries began catching up to his life. And then, getting ahead. He tested himself, wrote false entries, random gibberish, to prove the journal wasn't predictive. The false entries never reappeared. Only the real ones came back. Just too early. Like the book knew the story before he told it. The team called a halt to the simulation runs. They reinstalled all systems, flashed firmware, switched servers. The anomalies didn't stop. The black hole's region of sky, even when not observed, continued affecting local system memory. Not electromagnetically, not physically, logically. They began to wonder, what if the black hole isn't projecting anything? What if it's reflecting, not photons, intention, not because it understands, but because it's been seen too long. And now it's begun the only kind of communication it can manage, rewriting the minds that dare to map it. Roan's thoughts began slipping, not into madness, into order, too much order. His dreams followed recursive loops, patterns he could graph when he awoke, spirals, palindromes, sequences that mirrored the gravitational spin metrics of the black hole's accretion disk. He stopped dreaming in images. He started dreaming in waveforms. One morning, his team found a draft paper in the shared drive. It bore his credentials, his formatting style, his references, but he had no memory of writing it, and it ended with a statement he would never publish. We are not observing the black hole. We are participating in its memory. The observatory issued a silent moratorium. All simulations tied to frame 1439 were suspended. No further models would be tested. No neural mappings would be run. A quiet firewall was placed around the telescope's original telemetry dataset. Not to protect the data, but to protect the minds reading it. Because something had shifted, not in space, in perception. The researchers no longer trusted the shape of their own thoughts. Memories began to blur at the edges. Meetings felt repeated. Questions were asked before they were spoken. Some reported catching glimpses of whiteboards half erased. Notes they swear they never wrote. No hallucinations. No delusions. Just a subtle wrongness creeping into cognition, as if reality itself had become entangled with something bigger, and the threads were unraveling through attention alone. The more they tried to define the black hole, the more it began to define them. In the end, Dr. Roan left his journal open on a desk, its final page filled with ink that shimmered faintly under infrared light. The entry simply read, "It never wanted to be seen, but now that we have, it knows what seeing is." And beneath it, one final equation, a loop with no beginning and no end. Observation is meant to confirm. We look to prove. We triangulate to fix. We measure to make real. But what if reality doesn't want to be fixed? What if it waits for permission and sometimes doesn't give it? The anomaly surfaced during a triangulation routine. 3 satellites, positioned across Earth's orbit, were set to observe a simple gravitational lensing arc near the original frame 1439 black hole. The setup was clean. 3 angles, 1 coordinated simulation, and a patch of starfield expected to distort ever so slightly. It did, except for 1 star, a standard G-type main sequence light, cataloged and confirmed decades ago, expected to appear slightly shifted in all 3 frames. But in the second satellite's image, taken from the trailing Lagrange point, it wasn't just shifted. It was gone. No blur, no occlusion, just absence. The empty patch remained exactly the same shape, brightness, and spectral density as the space around it. Except where that star was meant to be, there was nothing. They checked for shutter glitches, sensor failures, cosmic ray hits, None explained the consistency of the hole, because even when the image was retaken, hours later, at a slightly different orbital speed, the star remained invisible to that satellite. From that angle, at that velocity, back on Earth, a deeper analysis began. The star's spectroscopic profile still registered. Light curves, thermal output, redshift, all measurable from the other two satellites. It wasn't lost. It simply didn't render from a certain vector. The team began experimenting with rotational speeds, slight frequency shifts, infrared overlays. Each time, the same conclusion held. The star existed, but only from specific perspectives, like a cosmic version of the double-slit experiment. Only this time, the uncertainty wasn't at the scale of particles. It was at the scale of stars. Some began to suggest that observation itself had become conditional. That near the black hole, whatever it truly was, space-time wasn't just warped, it was contextual. Reality became something like a user interface. Not all details loaded for all viewers. Some were hidden unless approached the right way, unless permission was granted. And so, the lensing arc once used to measure distance and verify the shape of spacetime was now reclassified, no longer as a constant, but as a selective reveal. The implications turned wild. What if that one star wasn't a fluke? What if countless objects, structures, bodies, even entire regions of space only existed from certain frames? Not in location, but in logic. One scientist proposed that the black hole near frame 1439 wasn't acting like a collapsed mass anymore. It wasn't absorbing, it was curating, as if the region around it had become a context engine, deciding, moment to moment, what truths were allowed to be shared between observers. What if the cosmos wasn't a place, but a conditional rendering of probabilities? What if the act of mapping it wasn't revealing its nature, but negotiating with it? A new term entered the team's private documents: reality gating. It described a phenomenon where visibility wasn't based on physical obstruction, but on logical eligibility. Objects passed through zones of reality the way software passes through layers of access. Depending on speed, angle, and observer status, certain features could disappear, not because they were gone, but because they were withheld. The theorists rewrote their models. The equations of general relativity remained intact, but nested inside them, new conditional variables appeared. Not just mass, energy, and curvature, but reference permissions. Some began to fear the implications, not for astronomy, but for ontology, because if the universe has conditional rendering, then what else isn't being shown to us? Not hidden behind distance, but behind viewpoint. The black hole may not be a well of gravity. It may be a negotiator, a decision point, not deciding who lives and dies, but deciding what counts as real, and to whom. One final test was proposed, not with satellites, but with human memory. A lab technician was shown a composite image of the anomaly from all three angles. She described the missing star, said it made her uneasy. But a week later, when asked to recreate the starfield from memory, she drew the star as visible in all three. Her recall overrode the inconsistency, and when shown the real images again, she insisted they had been altered, that someone had cleaned them up, but they hadn't. Her mind had restitched the truth to something more stable. The whole, it seemed, didn't just affect cameras, it affected expectation. And expectation, like gravity, bends what is seen. By the end of the month, triangulation protocols were suspended. The star was reinstated in the catalog, but with a footnote: visibility conditional on trajectory vector. Epistemic status uncertain. That footnote began appearing more and more, attached to stars, to galaxies, to fundamental constants. Not because they were changing, but because our confidence in their reality had become relative. The universe was no longer being measured. It was being asked, and sometimes it chose not to answer. Silence in space is a default, a background. It isn't strange when the stars are quiet. It's strange when they change the kind of silence they offer. For decades, the black hole cataloged near frame 1439 behaved as expected. It radiated Hawking decay in slow, predictable trickles. Its accretion disk spun with chaotic brilliance. Its presence was dangerous, but measurable, beautiful, but explainable, until the numbers stopped. No collapse, no flare, no spaghettified debris, just stillness. The radiation curve leveled. The gravitational pressure stabilized. The event horizon, a boundary that had always shimmered slightly with interference, suddenly flattened. Not disappeared, just paused, as if the black hole were no longer acting like a dying thing. It was waiting. The observatory team scrambled to confirm the data. Sensors were recalibrated. Background noise was filtered. Secondary satellites were consulted. One small probe, parked at a safe distance from the black hole's outermost sphere of influence, had remained passive for months, collecting telemetry, watching drifting. Then, at 3:17 Universal Time Coordinated, its sensors registered an anomalous ping. Not a transmission, not a burst, a gradient. Entropy levels shifted in a structured cascade, like a falling staircase of heat and order, arranged too perfectly to be coincidence. It wasn't noise, it was form, and within that form, the system's entropy mapping software detected a symmetry not native to physics. A question, not in language, not in binary, but in decay pattern, like a fingerprint left in heat, or a sigh carved into time. The scientists didn't know what to call it. They tried waveform analysis, trying to convert the gradient shifts into audio. It produced a faint hum, low, smooth, repetitive. Then they tried converting it to image, a brightness map over time. It resembled a loop, a Mobius ribbon, folded in on itself. But the loop didn't repeat. It reversed. The final frame was the first, but reflected backward. It wasn't communication. It was a mirror. The black hole, they realized, wasn't saying anything. It was responding, not to the probe, not to their math, to attention. It had noticed the observation, not in the way minds do, not thought, but presence, as if it had come to understand what it meant to be seen, and then decided to stop showing anything at all. Not as defense, as choice. In the days that followed, the radiation remained off. Background gravitational waves continued as normal. The hole was still there, but no longer active. It wasn't growing, wasn't shrinking. It had become a quiet coordinate in space, unmoving, undemanding, but now unwilling to be measured. That was the moment everything changed. Not because of fear, but because of realization. For centuries, humanity believed black holes were endpoints. Places where time dies, light halts, matter collapses. But this one had done something no death does. It paused, it listened, and when it heard enough, it chose silence. What followed was not panic, not revelation, but humility, because the question shifted from, what's inside the black hole, to, what if it's not meant to be known? And deeper still, what if some parts of the universe are built to hide? Not because of physics, but because of intention. Not intelligence, not malice, just a mechanism within reality that knows when it's being watched and decides what it will offer in return. Across observatories, other researchers began reporting minor entropy disturbances near known singularities. Small deviations, moments where the math felt too perfect, then abruptly stopped aligning. Not noise, Not malfunction, redirection, like the cosmos adjusting its mirrors, turning certain corners away, refusing to let some lights shine. The final report, classified under an obscure internal protocol, included a haunting closing note. We once thought black holes were the universe's graveyards. We now suspect they are its vaults, some for matter, some for memory, and some for answers no mind should hold, because the truth was never inside the black hole. It was around it, in the frames that vanished, in the memories rewritten, in the stars that blinked from some angles but not others, and finally, in the soundless silence that followed its last reply. A reply that said nothing, but felt like being watched.